Hey guys, in this video we are going to talk about what net force is and how to calculate it. Net force 101. So let's begin. Net force is a really simple concept. It's the combination of all the forces acting on a single object, and it gives you one number and one direction. You calculate net force by either adding or subtracting. You add forces that are moving in the same direction, and you subtract forces that are being applied in a different direction. You've got to really pay attention to the direction that it's describing the force or the arrows that it uses, because sometimes it can get kind of tricky, but as long as you know which direction it's going, you can figure out what the net force is. If the net force is 0, then the forces are balanced and its motion won't change. And remember, balanced forces can either be at rest or at a constant speed or a constant motion. If the net force is not 0, the forces are unbalanced and the motion of the object will change. So before you move on, you need to memorize these. Write them down, practice them at home. I don't know, just whatever you need to do to memorize these. When it comes to net force, you'll always see the unit for force, but these others are very helpful as we move forward with Newton's laws of motion. So pause the video and write these down. You have 4 variables here: force, mass, velocity, and acceleration. The unit for force is newtons, and that is named after Isaac Newton. So that's why our unit symbol is a capital N right here. Mass is usually in kilograms, and its symbol is a lowercase kg. Velocity is meters per second, which is represented by the m divided by s. That means per. And acceleration is meters per second squared. That's how you say this. The m/s with the little 2 at the top. So again, pause the video and write these down. Ooh, excuse me. So let's do some practice. We have 5 problems, and you'll want to write these down in your journal to practice calculating net force. So problem number 1 is a box was at rest on a table when the forces shown below were applied. So based on my keyword here, rest, I know the forces are balanced. It's not moving. All right, so I have a 5 kilogram box, and the forces applied were 10 newtons to the right and 20 newtons to the left. Now pay attention to the direction the arrow is moving. What is the net force acting on this object, and how will the object's motion change? So the net force acting on the object is the sum of all the forces acting on it. And remember, we subtract forces moving in the opposite direction. Since these are moving in the opposite direction, that means we subtract these 2 forces. So 20 minus 10 gives us 10. And that means that since the net force isn't 0, the object's motion will change, and it will start to move to the left because the force moving to the left or being applied to the left is bigger than the force moving to the right. And since it was at rest, I know it's going to start moving. Now you'll notice that there is a mass of the box, and we don't need it in this situation because we weren't asked anything regarding the mass. So it is just important, though, for you to understand that this kg refers to mass. All right, problem number 2. A box was moving to the left at a constant speed when the forces shown below were applied. So it was moving at a constant speed, and then 10 newtons of force was applied going to the right, and then 7 newtons of force was also applied going to the right. So since they're moving in the same direction, we add them, which means our net force is 17, and it will change direction and move to the right, because originally our problem said it was moving at a constant speed to the left, but our forces were applied to the right. They were both going in the same direction, 17 newtons, so it's going to change direction and move to the right. Problem number 3. A box was moving at a constant speed to the right when the forces shown below were applied. So I have 14 newtons and 3 newtons, both moving to the right. So it's going to, the net force is 17 because they're both in the same direction. So we add them, and it's going to accelerate faster to the right. It was already moving at a constant speed to the right. The forces were applied to the right. So, and since our net force isn't 0, it's just going to change its motion. It's going to accelerate it. All right, problem number 4. A box was at rest when multiple forces were applied in the amounts and directions shown. So you might be thinking to yourself, like, wait, what? I don't understand all of these zeros. And that's okay. Just remember, net force is a single number, and that does mean that you're still adding forces in the same direction and subtracting forces in different directions, and that includes whether they're horizontal or vertical. So to calculate the net force acting on this object, first focus on the horizontal forces, and then you can deal with the vertical forces. So in the horizontal plane, we have 15 newtons moving to the left and 10 newtons moving to the right. So my net force horizontally is 5, and then vertically, I have 2 newtons moving up and 1 newton moving down. Those are different directions, so I subtract those as well. So that gives me 1 newton moving up, 5 newtons moving to the left, which makes my net force 4, because 5 minus 1 is 4. And then it will move to the left and up, because the 15 newtons moving to the left was bigger than 10, and 2 newtons was bigger than 1, and it was moving up. Tricky, but not impossible. Our last problem is just a word problem. It will help you if you write this down and draw it out the way that the previous problems had a picture to go with them. A ball resting on the floor is kicked with 15 newtons of force to the right. If the force of friction between the grass and the ball is 20 newtons, what is the net force acting on the ball? Now, the first thing you need to ask yourself is, are these forces going in the same direction? And if you're drawing it out, your 15 Newton force arrow would be pointing to the right. Your 20 Newton force, since it's friction and friction always opposes motion, it's going to be moving to the left, which means they're not in the same direction, and our net force would be calculated by subtracting the 2, which would give us 5 newtons. That's it. If you have any questions, go back and rewatch the video, or better yet, go ask your teacher to help you solve your problems.